So this is just going to be a quick introduction to something called stoichiometry. I know that the word looks pretty intimidating, but it's actually not that difficult to say. So it's just up there, stoichiometry, and that's it. It sounds complicated. It's sort of complicated, but I don't know. I just feel like it's like logical. It makes sense. So your essential question is, if we have an infinite supply of graham crackers and chocolate, but only one marshmallow, how many s'mores can you make? Yeah, you can only make one. That's kind of like the idea of stoichiometry, except it's not as delicious. It is like dealing with chemicals. Stoichiometry can just help us answer questions like how much product can we make? So for example, like how many s'mores can we make given the number or the amount of like graham crackers, chocolate, and marshmallows we have? And it can also tell us like how many of each reactant do we need? So looking at this is just the chemical reaction. Do you guys know what type of reaction this is? What did you say? Combustion. How did you know it was combustion? Lucky guess.
It's a combustion engine.
Yep, so you can see that there is something clearly burning here. But remember, whenever you have a combustion reaction, you're generally going to be starting out with a hydrocarbon and oxygen, and your byproducts are always CO2 and H2O. So this is a chemical reaction all balanced out for the combustion of octane. And it's just showing you that if you have 2 molecules of octane, how many molecules of carbon dioxide will you produce? 16. How many molecules of water vapor do you produce? 18. So it's just kind of a way, like stoichiometry and balanced equations just helps us quantify how many reactants and products we are using. So got a couple things to fill in right here. And stoichiometry just helps us calculate the chemical quantities. So like how much reactant we need or how much product are we going to make. It's really important that you balance the chemical equation first because you need to know how many molecules are involved in the reactants and the products. So you have to use something called a mole ratio. It's literally just a ratio of the coefficients in a balanced equation. So the mole ratio in that example I gave before about like the burning of octane, for every 2 molecules of octane, we make 16 molecules of carbon dioxide. So that is the mole ratio. This is why you need to know how to balance your chemical equations. And so we are going to use something simple to begin with, just looking at s'mores. And so we're going to give the s'mores fake like chemical symbols. So we've got our graham crackers are G, our chocolates are C, our marshmallows are M, and then our final s'more, we're just combining it into G2C3M. So how many graham crackers do we need? Like what would, if we were balancing this equation out? We need 2 pieces of graham cracker. To make a true s'more, how many pieces of chocolate do you need? 3. And that's like, I'm talking like if they're normally, if you were breaking this off of a Hershey's bar, they'd all be connected. But I want you to have like the 3 little rectangles. And how many marshmallows per s'more? 1. And then this will give us 1 s'more. So if we were doing one of these examples where the question is how many moles of s'more can you produce with 27 chocolates? So whenever you do, the way that I always start out one of these word problems is I underline my given, so what I'm starting with. That way I know what I'm putting in that first box. And then I circle my wanted, so I know what I'm trying to convert to. My conversion factor, if I'm dealing with chocolates and s'mores, for every 3 chocolates, I can make 1 s'more. And so I'm always going to use this as my placeholder. You're not going to put anything in that bottom left box. But what do you think we're going to start out with? Are we going to start out with chocolate or s'mores? Chocolate, yep, because that's our given. So you're going to start out with 27C. And then which unit do you think we should have on the bottom here? Chocolate. Good job. And how many chocolates do we have in our balanced equation? 3. And how many s'mores can we make if we had 3 chocolates? 1. And so just like we've done in the past, you multiply the top and divide the bottom. Our chocolates cancel out. So based on how much chocolate we have enough chocolate to make 9 s'mores. So I have the steps already for you on the page, but the first thing you have to do, you have to make sure your equation is balanced, or else you won't know which coefficients to put in your conversion factor. And then you always start with your given. Your conversion factor goes on the second part with the given on the bottom, so it cancels, and the wanted on top. And same thing as before, you just multiply the top and divide the bottom. So now we're going to try it with a real chemical equation. So balance this one out on your paper. Okay, so if we want to balance this out, we're going to need 2 nitrogens. I don't know why my first one didn't come out. But you're going to put a 2 in front of the NH3 so that it matches the 2 on the left. And then you're going to need, now you have 6 hydrogens on the right, so you're going to need to make the middle one 6 hydrogens as well. So starting out with our conversion, we are starting with 5 moles of NH3, that's ammonia. And what are we trying to convert to? What's it asking us to calculate? Yep, so we're trying to get to hydrogen. So if we set up our conversion factor, remember we are dealing with NH3 and H2. So for every 2 NH3s, which you can see over here, we need 3 H2s. So that's our mole ratio. It's just whatever the coefficients are up at the top. So we've got our smiley face placeholder. What's going to go in that top left box? Yep, 5 moles of NH3. And then we're going to want that to cancel out. So we want moles of NH3 to cancel. So we're going to put NH3 on the bottom of our conversion factor. And what number's in front of NH3 in our balanced equation? 2. So we have 2 moles of NH3, and then what's going to go on top? And how many H2s? Good job. And so multiply your top, divide your bottom. What's 5 times 3? 15. And what's 15 divided by 2? 7.5 moles of hydrogen. So that means if we wanted to make 5 moles of ammonia, we would need 7.5 moles of hydrogen. We're going to do one more example. So this time we have, we're saying that we need 7.5 moles of hydrogen. So then we want to know how much nitrogen do we need if we wanted to use up all of that hydrogen. So our given is 7.5 moles of hydrogen. Our wanted is moles of nitrogen. So that means our conversion factor is for every 3 H2s, we need 1 N2. So start with your given in the top left and see if you can set that one up on your own. Okay. So since we're starting out with H2, we want the H2 to go on the bottom of our conversion factor. It gets a 3 next to it, because there's a 3 coefficient in front of it in the equation, and we're trying to get to N2. So we're going to have 1 N2 on top because there's nothing in front of the N2 in the beginning, so we're just going to assume a 1. So they cancel out, and what did we get for the answer, Jake? Good job, 2.5 moles of nitrogen. So that means if we have 7.5 moles of hydrogen and we want it to completely react, we need 2.5 moles of nitrogen. So that is it. You can work on the practice on the back if you want, but it's not required because you can do it next class. I really would prefer you study for your mole conversion quiz.